Challenges in gas turbine. In this video, we will discuss about what are the challenges in gas turbines. So, the gas turbine is commonly operate under extreme conditions of high temperature, pressure, and stress. These harsh conditions pose several challenges to their reliable and efficient operation. So, is the common fact is the thermal stress and fatigue. So, it's a high temperature gradients. The uneven heating within the turbine blade, particularly at the trailing edge, leads to significant thermal stress and fatigue. And the trailing edge vulnerability is the trailing edge being the thinnest part of the blade is most susceptible to thermal fatigue, often indicating cracks. And blade failure mechanism is elevated temperatures, is high turbine inlet temperatures, increase heat transfer to the blade, weakening its structural integrity, and thermal stresses. So temperature variations within the blade material generate internal stresses, potentially leading to cracks and fading. And coating degradation, it's a productive coating. Turbine blades are coated with materials like ceramic to withstand extreme temperatures and prevent oxidation. And adverse conditions, high gas velocities, particulate impact, and thermal cycling can degrade these coatings over time. And leading edge vulnerability, the leading edge being the first point of contact with hot gases is particularly prone to coating degradation. And corrosion and erosion, so fuel impurities. Gas turbine fuels often contain corrosive elements like sulfur, vanadium, and sodium. Corrosion attacks. These impurities react with blade materials at high temperatures, leading to corrosion and weakening. And erosion damage. Particle impact is ingestion of dust, sand, or other particulates in the gas stream can cause erosion of blade surfaces. Thermal barrier degradation. Erosion can damage the productive thermal barrier coatings, exposing the underlying blade material to high temperatures. Increased fatigue. This damage accelerates thermal fatigue and the crack formation, reducing blade lifespan. Cooling system importance is extreme operating temperatures. Gas turbine operate with combustion temperatures far exceeding the melting point of blade materials. Cooling system necessity. An efficient cooling system is crucial to extract heat and maintain blade temperature within operational limits. Extended lifespan. Effective cooling mitigates thermal stresses, reduces fatigue, and significantly extends the operational life of turbine components. And types of cooling system. Internal cooling utilizes complex networks of channels within the blade to circulate cooling air. Unfilm cooling. It involves a thin layer of cooling air onto the blade surface to create a protective barrier. So these are the some failure, some toughest challenges condition in gas turbine engines, and summarize is elevated temperatures, thermal stresses, protective coatings, adverse conditions, leading edge vulnerability, and fuel impurities, and corrosion attacks. These fuel impurities in gas turbine fuels often contain corrosive elements like sulfur, vanadium, and sodium. And corrosion attacks and these impurities react with blade materials at high temperatures, leading to corrosion and weakening. And erosion damage is a particle impact with injection of dust, sand, or other particulates in the gas stream can cause erosion of blade surfaces. And thermal barrier degradation, if erosion can damage the productive thermal barrier coatings, exposing the underlying blade material to high temperatures. and it increased fatigue is the damage, accelerate thermal fatigue and crack formation, reducing the span. And also the cooling system, importance is the extreme operate temperatures, cooling system necessity, extended lifespan. And the final one is types of cooling is a two categories is internal cooling and clean cooling. So these are the summary and small video lectures in part of challenges in gas turbine engines. Thank you.